Hi, how's it going? We've got another calculus video here for you. Let's get right into it tonight. Section 1-2. We're going to split 1-2 up into two videos actually, because there's a good amount of information here, and I certainly don't want you sitting there watching videos for an hour. So we're going to look at analyzing functions. And what we're going to do is we're going to look at 6 different areas or 6 characteristics, properties, whatever you want to call it, that functions have that distinguishes one from the next, makes one look different than the next one, so on and so on. So let's get right to it here. It's real important that you understand what each of these 6 do to help you figure out that picture of that function. The first one is domain. We've talked about domain a good number of times here the last few sections. Remember, domain again is just the x values. Alright, so what x values can you plug into the function? Okay, what are the x values that you can put in? And probably a better question or something to follow up is, how do I determine that? What do I do to figure out what values can go in? That's a really good question. I guess start thinking about, when do you have undefined values? That will have an effect on your domain. Right? If a function is undefined, then that's an x value that you can't plug into your domain. All right. How about range? Now, range, remember, it's just the other opposite side of that. It's what are the numbers that are going to come out of the function. And again, what's the purpose of knowing that or being able to recognize that? Well, again, that's just so you can see on your graph how far up or down it's going to go. Okay, remember, again, that controls the y value. Alright, so that's our range. So domain and range gives you an idea of where this function is going to be, left, right, up, and down. Kind of getting ahead of ourselves a little bit, because we probably need to look at, is this graph or equation or whatever, is it even a function at all? Alright, are we actually looking at a function? Because if we're not, then a lot of these things we're talking about really are pointless. So if it's a function, I mentioned this the other day, it has a one-to-one correspondence. Again, what does that mean? It means that for any particular x value, when you plug it into the function, you are only going to get one y value from it. Alright? We can check for that by doing what's called the vertical line test. And so here's an example of that idea. I've got myself just some kind of weird function here, and if I draw a vertical line on this graph anywhere, alright, anywhere, right through the y-axis, way over on the far left, way over on the far right, anywhere on this problem, okay, when the behavior of the function is changing, like going up and then it's going down, whatever. But if I draw a vertical line on that graph, I should never be able to hit more than one point on that graph. If I do, then what that really means is, for that particular x value, there are 2 y values that correspond to that, and that is not a function. Right? That fails the definition of what a function is. Alright? It's okay if it crosses 0 points. That just means the function isn't defined for that particular x value. Alright? That's kind of a visual representation of when our domain changes. But again, you can see in all those cases, just 1 point at most. Alright, so that's our vertical line test, and I hope that you've seen that in the past somewhere. But that is a test to determine if a graph is a function. Okay. Number 4. Now we start getting into things that are a little bit more mathematical, I guess, if you will. Finding the zeros or the roots of a function. I kind of prefer the word roots, and the reason I prefer the word roots is it's where the function crosses or digs into the x-axis. Alright? And so to find that, what we're going to do is we can set the function equal to 0, and we can solve it. And hopefully you can find all of the solutions. Many times there'll be multiple solutions. In fact, there'll be as many solutions as the degree of the equation is. Remember, degree just means what the exponent is. You can also use your graphing calculator. So if you're not great at the algebra part, you can use your graphing calculator. There's a really good YouTube video. Just do a search for finding roots and vertex with your TI-84, and it's a really short, easy YouTube video that walks you through the built-in features of your calculator. Alright? Talk a little bit more about that. The next area is, when is the function increasing or decreasing? Okay, so you'll hear expressions called increasing and decreasing functions, or increasing and decreasing intervals. Just in real simple talk, all that is when is the function going up, when is the function going down. That's all it means, as I'm moving from left to right. Alright, if I'm moving from left to right and the function's going up, it's increasing. If I move from left to right and it's going down, it's decreasing. So you can choose to do a very low-tech approach and just plug in some values for x and see what happens to your y values that come out. Or again, I think you just graph it. That's by far the easiest way to do it. Graph the function and see for yourself. When's it going up? When's it going down? Okay? Not a particularly hard idea, unless you've got a lot of changes. Unless your function goes up and down and up and down, and it occurs at unusual values. And then, so yeah, here you go. Here's an example of that. I'm just kind of making some numbers up here. Let's say that's negative 2. And then we got the origin here, and then let's say over here to the right that's 3. Alright, and so we would say then that this function is increasing from negative infinity all the way to negative 2. Alright, so we always write it as an interval in terms of its x values. And then once it gets to negative 2, it hits that peak and it comes back down, so now it's decreasing from negative 2 to positive 3. And then at that spot, when it hits that low point, it goes back up, so it's increasing from 3 to positive infinity. That's how you would write those increasing and decreasing intervals. Pretty straightforward. I wouldn't think it's the hardest thing of our 6 features here, is that. And then last but not least, and this is kind of related to what we just did, does the function have any maximum or minimum values? And really what we're looking at are the ones that are sometimes referred to as relative max or min, or relative extrema is a fancy way of putting it. And again, all that really means is, are there spots on your function that are the smallest y value in a particular area, and is there a spot on your function where it's the largest y value in a particular area? And for now, we'll do this a little bit later, a little bit different later on, but for now, just use your calculator for this. All right? Again, you can look at a graph of it, or you can use the built-in function. So you go back to that video and where it helps you find some of the vertices of those functions. You can go under the second calc menu, the trace menu, or second trace, excuse me, and use some of those built-in features. So when you do this, you're really looking for the peaks and the valleys of your function. And so if we go back and we look at that example that we just did with the increasing and decreasing values, we should be able to identify a maximum and a minimum there. Now when you do maximum and minimum values, you're going to write those as coordinates. Alright, so we'll write them as xy coordinates. So let me scroll back up here to the problem that we did. And so again, I'm making up some numbers here as I plug this in, but over there where it goes up, 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 and then it stops going up, that's a maximum. So in that particular area of the graph, that's the biggest value. And so we'd say that there's a maximum at negative 2 comma whatever 4. Alright, that's a max value. And then obviously over here, when it goes down, 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 and it stops going down, that's the lowest value in that particular area. So 3, again I'm making up negative 5 here, 3 negative 5 is a minimum, or a relative minimum for this function. So why don't you try one here? I'll give you an example. Again, once you see the problem and the things I'm asking you to do, press pause, try to do it on your own, and then come back and compare your answers. So let's say our function is x squared plus 8x plus 12, and let's find all the things that we've looked at in this video, all 6 things. So domain, range, is it actually a function? What are its roots? What are the increasing and decreasing intervals for this particular function? And then does it have any maximum or minima? And what are the coordinates of those? Alright, so whenever you want, press pause, and then I'll come back and I'll talk to you here in just a moment. Alright, so how'd you do on this? Were you able to answer all 6 of those? I'll go through these kind of slowly here to explain a little bit as I go. The domain should be pretty easy. That's all real numbers. You say, how do I know it's all real numbers? Because there are no numbers I can't plug in for x. Easiest way to tell is that there's no fractions in this problem. You know, so there's no possibilities of being undefined. If you looked at a graph, there's no holes or jumps or anything like that. It just goes for any x value imaginable. Range, a little bit harder. You're probably going to want to have to graph that and just kind of look and see what's my smallest y value, what's my biggest y value. Since this thing goes down to negative 4, but it goes up forever, so your range is going to be any values negative 4 on up. So if we wrote that in the interval notation, that'd be negative 4 comma infinity. Range is, and we're going to include negative 4 obviously, because that's where that vertex is at. Range is not a super useful part of this, but it is a small part. Is it a function? Well, if I graph it, it's a parabola, and no matter where I draw a vertical line, I'm not going to hit any point on that parabola more than once, so it passes the vertical line test, so we're cool there. But its roots. Hopefully you got 2 roots for this problem, negative 6 and positive 2. Again, you could do that negative 6 and negative 2. You could do that algebraically, or you could do that with your built-in functions on your calculator. This is going to increase from negative 4 to infinity, and it's going to decrease from negative infinity to negative 4. Again, a picture of the graph would help with that. And so that means that this has got a minimum at negative 4 comma 4. I'm sorry, negative 4 and negative 4. And no maximums to this one. Alright, so homework, if you want to get a head start on your homework for tomorrow, that's going to be on page 94, and feel free to do some of those problems there, any of them from 23 to 68. Alright, see you next time.